At a distance of about 13 billion light-years, the most distant supermassive black hole known so far has been spotted by an international team of astronomers. That incredible distance means the object dates back to the time when the first stars blinked on, which raises the question of how a black hole that big arose so soon after the universe began. The newly discovered black hole is part of a quasar, meaning it sits at the center of a cloud of gas that it's slowly swallowing. As the gas falls into the black hole, it speeds up, heats up and brightens, which allows astronomers to see them from across the universe. Quasars are among the brightest and most distant known celestial objects and are crucial to understanding the early universe, says Bram van Emmons of the Max Planck Institute, co-author of a study describing the discovery. This quasar was first identified in data from NASA's Wide Field Infrared Survey Explorer-WISE program, then studied in closer detail by scientists using Carnegie Observatory's Magellan telescopes in Chile. There, a spectrometer known as the folded port infrared egalifier was able to determine the object's distance and mass based on its redshift. Since the universe is constantly expanding, distant objects are moving away from us, which stretches out the wavelength of the light they emit. That means the light shifts towards the red end of the spectrum, and the higher an object's redshift, the further away it is. With a redshift of 7.5, the newly discovered quasar began emitting light a mere 690 million years after the Big Bang, and the supermassive black hole at its center has 800 million times the mass of our Sun. It's not the brightest or most massive. That honor belongs to a quasar called SDSS-J01002802, which boasts barely comprehensible stats like a mass of 12 billion suns, and a luminosity of 420 trillion suns. But this newly discovered black hole is more than 200 million light-years further away, and hence, 200 million years older. That dates it to a time when the first stars started to light up the inky blackness of the early universe. As stars and galaxies began to fire up and release energy, the photons they emitted ionized the neutral hydrogen gas that previously filled the universe, marking a fundamental turning point in history. Using fire, the researchers determined that at the time this quasar began emitting light, the hydrogen gas around it was half neutral and half ionized. What we have found is that the universe was about 5050. It's a moment when the first galaxies emerged from the cocoons of neutral gas and started to shine their way out, says Mitz Robert Simcoe, co-author of the study. This adds to our understanding of our universe at large because we've identified that moment of time when the universe is in the middle of this very rapid transition from neutral to ionized. This is the most accurate measurement of the time, and a real indication of when the first stars turned on. But there's a problem with the finding. The black hole appears to be far too big for its age. According to our current understanding, it should take more than 690 million years for a supermassive black hole to accrue the mass of 800 million suns, so the researchers suggest there must be another unknown mechanism at work. This is the only object we have observed from this era, says Simcoe. It has an extremely high mass, and yet the universe is so young that this thing should exist. The universe was just not old enough to make a black hole that big. It's very puzzling. The research was published in the journal Nature. View Gallery 2.